Okay, now let's take a look at two other types of regression. One is Lasso, and the other one is Ridge, which is down here. Here it is. And what we want to do with these two is these are two different types of regression models that do different things. So Lasso is trying to only use the fewest number of variables to be able to predict our target variable. So what it does is it takes all those coefficients and tries to make them all zero except the most significant ones. Ridge, on the other hand, tries to use every one of the variables, no matter what, and use it to be able to predict our variable. So what makes these different? Lasso will take 20 and basically say maybe 5 or 6 or 8 are the significant ones and the other ones don't matter. Where Ridge is going to see those 20 and say, let's try our best to use all 20 and come up with the best prediction. So if you're trying to figure out how to come up with the fewest number of predictive variables, then you want to run Lasso. If all you care about is the final product and you're willing to throw everything into that model that you can, then Ridge is what you would use instead. So that's the two different differences there. So I'm going to go ahead and run to import the model, create our just a variable so that it represents Lasso. Go ahead and use our X-train and Y-train variables. And I go ahead and fit, and I predict, and I see my score of 0.64. So that's my R value for this. I'm going to go ahead and create a names one so that we can do a better job. And now let's take a look at all of those coefficients. So if you go up here, you see these values in this column. These are coefficients. It's what makes up the regression equation. We're going to do the same thing here and see what those look like. And there you go. And you see a lot of these are set to 0 with only number 5, 10, 11, and 12 as significant variables in this case. So I'm going to go ahead and add the column labels so we can see what that means. So what does that mean? That means number of rooms, the PT ratio, B, and LSTAT are the ones that they say are the most significant in predicting the price of a home, and therefore only need those as part of this model. And the rest we could throw away, and what we will have is an R-squared value of 0.64. So let's try the same thing except using Ridge and see what happens. So we fit the model, we then predict with the model and take a look at the score, and it's 0.704. Not surprisingly, it's better because what it does is it includes all the variables as opposed to just 4 of the variables. So I'm going to go ahead and run to look at these coefficients. And in this case, you see what happened here. It includes all of the variables and each one has a coefficient. So it will, in most cases, I can't imagine why it would never be more accurate, but what you have to determine is it worth that extra accuracy to include all of the variables? If these variables are very hard to collect and to import, because it's hard to get the data, then maybe you want to go with your Lasso regression model. But if it's very easy and all you're doing is pulling from an API and it's already readily available to you at any moment, then maybe Ridge is what you can use, and that'll be a better predictor for what you're looking at. So that's it with regression. So we've gone through and looked at simple regression, multiple regression, how to build a model, and also Lasso and Ridge. And that helps us figure out which independent variables are significant, as well as how to predict a target variable with independent variables.